Example 1, graph one cycle of the function f of x equals 3 minus tangent of x over 2. The first thing I like to do is rewrite the equation so it's in the order we're used to things being in, with the 3 at the end and the trig function first. So I've just swapped the two terms in place. Okay, so now let's identify the important details about our graph before we start to sketch it. So the negative in front of the tangent indicates it's going to reflect over the x-axis. The period is going to be 2 pi, and that's because omega is 1/2 because of this x divided by 2 in the parentheses. And so to find the period, we take the normal period of tangent, which is pi, and we divide by the omega value, which is 1/2. And when you divide by a fraction, you flip it and multiply it. So that gives us a period of 2 pi. And then 3 is our vertical shift. Okay, and before we get going too far on this, I feel like I want to think about the asymptotes really fast. So I don't know if I'm a little tired today or if it's just because I don't do tangent every day and I forget things, but tangents, asymptotes are pi halves and 3 pi halves. So if we have an omega value of 1/2, that's going to take our asymptotes that are normally at pi halves and 3 pi halves, and it's going to divide that by 1/2, which means we would multiply by 1/2, which is going to take our asymptote and put it at pi instead. So there's one asymptote. And then let's do another asymptote just to make sure we've got this. So there would have normally been one at 3 pi halves, but because we divide that by 1/2, we multiply the 1/2 and the 2's cancel out. So that's going to be at 3 pi. So we've got asymptotes at pi and at 3 pi. And because the period is 2 pi, our asymptotes are going to repeat every 2 pi, right? So we could write that as pi plus 2k pi if we wanted to give infinitely many values for those asymptotes. Okay, grab my line drawing tool to do my asymptotes in here. So I'm going to put one at what I'm considering pi and then skip clear over to 3 pi. That means there would also be one at negative pi. And like I said, you can graph these any way you want as long as you label them correctly. You could honestly take one tangent graph pretty much and just relabel it to make it fit a new period or a new vertical shift or something like that. So there's some asymptotes for us. And then tangent is reflected, which means it's going to look a little bit more like cotangent. It's also shifted up 3, so we probably want to not forget that that midline is moved up 3. There, I'll just use that for our midline moving up 3. So reflected graph, midline is up 3. Between these asymptotes that are further apart because the period is bigger than we're used to. So our graph should end up, this is not perfect. Your graphs themselves don't need to be as perfect as your understanding of the details of the graph. For example, another detail you might want to know on this besides where the asymptotes are is that there are points at this point, 0, 3, because that would have been at 0, 0, but it's moved up 3. And then there's a point here at 2 pi 3, because the period is 2 pi and the graph is shifted up 3, so that's where our next intercept would have been, but it's up 3 instead. So just be aware how your graphs look is less important than knowing what your graphs are supposed to look like and where the points are that your lines should be crossing through. Things like that. Not like all the points, but some basic points, basic things like domain and range, so the domain would be everything except for pi plus 2k pi, and the range is still all real numbers. Nothing has changed that.